God bless you and peace be with you, honors calculus students. I'm making a video right now to help you better understand implicit differentiation, and I've got one question also which I assigned on related rates, so I'd like to be able to go through this with you. One of them I assigned you is page 160, number 101, and it's a good idea to just look at the function that you're given and somewhat decide in your mind what kind of differentiation will be required here. Here you can see we clearly have a product. You could make this product x times y with the 3 on the outside, and here this will be just simple differentiation with respect to x, and here's differentiation with respect to y. So as I've showed you before, let's go ahead, and since we're looking for dy by dx here, this d dx simply means we're differentiating with respect to x. We're going to do it on the left side, and we'll do it also on the right side. So here we go, d dx, or derivative with respect to x of the left side, is equal to the derivative with respect to x of the right side. And I've said to you before, it's just like algebra. Whatever we do to one side, we do to the other side. Okay? And yes, the song is true. It says, the principle of justice stands. The principle of justice stands. The principle of justice stands. It stands in every land. God embraces justice. Anything else tends to make him sick. Equality and equity flow from his heart. What you do on the left side, do the same thing on the right hand side. If you do the derivative on the left, do the same thing on the right side. That's how the principle of justice stands. The principle of justice stands. The principle of justice stands. It stands. Let it stand. It stands. So that being said and sung, let's take it in bite-sized pieces. We're going to go derivative with respect to x of x squared plus, I'm going to take the constant outside and do the derivative with respect to x of this product xy plus derivative with respect to x of y squared equals, and we know the derivative of 0 is going to be 0, or the derivative of any constant is 0, so we've got that. So but step by step now, derivative with respect to x of x squared, I'm sure you're just shouting, I know what that is, that's 2x plus 3, and here's where we have to be very careful, but I'm sure we can do this. We're going to do a dear b, so let me just break it as we should. This is one factor, which is the x, and the other factor is the y. So we're going to do x times the derivative of y, and you know the derivative of y is dy by dx, plus y times the derivative of x. Derivative of x is simply 1. That product is done, and we come to the derivative of y squared, and that's going to be 2y. We're doing dy with respect to x. That's going to be equal to 0, and the drill is going to be the same. We want to leave the dy by dx terms on the left usually, put all the other terms like this one when we distribute the 3 through on the right side, and we get this. We get 3x dy by dx, and we distribute 3 over this. And then we have the 2y dy by dx, which I'm going to put on the same team here. And that will be equal to distributing the 3 over the y and bringing it to the other side. It's going to be a negative 3y. And moving the 2x to the right side, I get minus 2x. Alright, let's finish it up here, because I got something on the other page, so I don't want to go there. So I'm going to factor out a dy by dx from this term and this term. So I got dy by dx coming out, and that leaves me 3x from this term plus 2y equals, on the other side, I'm just going to take out a negative and make it 3y plus 2x. And as you know, dividing both sides by the coefficient of dy by dx, I get dy by dx. It's going to be equal to negative, in parentheses, 3y plus 2x all over 3x plus 2y. And I know they look alike, but please don't confuse them. They're not the same. We leave it like that. Alright. Just looking at this briefly, we would get an undefined slope if x is 0 and y is 0. So at the origin, the slope would be undefined here. X is 0, y is 0, and for some other x values as well. Okay, we'd get a horizontal slope. That means the slope would be 0 if the numerator is 0. Okay, so undefined or vertical. These are some questions that come up. Slope if the denominator is 0, so x would have to be 0 and y 0. That's at the origin. And then a horizontal slope, and you know horizontal slope is when the slope is 0, right? Horizontal slope would occur if 3y plus 2x is 0. That also, I imagine if we solve this by saying 3y equals negative 2x, if we put x is equal to, I imagine if we put x is equal to 0, then we get 3y equals 0. It looks like at the origin also we'd have our horizontal slope. Okay, we'll go into that another time. I think maybe I'm trying to put too much in it. I just really want you to see the implicit differentiation right now. We'll deal with this another time, all right? Let's take a look at related rates. On page 154, I gave you number 15, and here it is, page 154, number 15. It says, the radius of a circle is increasing at a rate of 3 centimeters per minute. And let me quickly say, radius increasing means it's a positive thing. It's increasing. And what that means is that dr by dt is equal to a positive 3. And that's the way it should be in life. It's good to be increasing, particularly in our knowledge of the Lord Jesus Christ. And it's positive 3 centimeters per minute. Okay? And this dr by dt means our radius is changing with respect to time. So I've written this out in a derivative way. What else are we given here? It says find the rate of change of the area when r is equal to 6. Rate of change of the area. What does that mean? That's what that means. dA by dt is how the area is changing with respect to time. They want us to find that when r is equal to 6 centimeters. Okay, after a while I trust you'll really get to like these. We're talking about a circle. The radius looks like this, and of course the area is given by A is equal to pi r squared. So since we want to find how the area is changing with time, we do the derivative of the left side with respect to time. And as I just sang, that must be equal to this derivative of the right side with respect to time. I want to take the pi on the outside because pi is not a variable, so it's just going to be a constant like that. You can always do that. It's kind of nice to do that. So here I got dA by dt. It's going to be equal to pi times, what would be the derivative of r squared with respect to time? Well, Sam told us yesterday, so I'm sure you remember 2r, and we're done, right? Not quite. dr by dt. Since the variable t is different from the r, we have to do dr by dt. So this in essence then would be 2 pi r dr by dt. So now let's put it all together. They tell us that dr by dt is 3, so we can put the 3 in here. And they want us to find dA by dt when r is 6, so we're going to put the 6 in here for r. And here we go. What we seek, dA by dt, is going to be equal to 2 pi r is 6 and dr by dt is 3. So putting it all together, we get 6 times 2 is 12, 12 times 3 is 36. This is going to be 36 pi. I wonder if someone could give me the units. How area is changing with time. We've got centimeters, and area, you know, here would be centimeters times centimeters. So it would be centimeters squared per minute. Okay? May God bless you and open your understanding that you can see these more and more clearly. And maybe one other quick thing before I close it off here. I gave you this formula, and that would pertain to numbers 1 through maybe 7. 1 through 7 on page 54. 1 through 7. And here's the recipe I gave you. dy by dt is equal to dx by dt times dy by dx. Okay? You can see that the x's would cancel, dx would cancel. So if you know any of these, if you know 2 of these, let's say you know this and you know this, then you can find dy by dt. Similarly, if you know dy by dt and let's say dx by dt, then yes, you can find this one. Alright? So if you know any 2 of these, this and this, you can find this one. If you know, let's say this one and this one, and you can certainly find that one. Okay? So that's a little extra there. Next week, possibly I'll put another one up in preparation for your test. But God bless you and keep you, and I look forward to seeing you next week, if not before. Bye-bye.